Welcome to the world of high-speed physics, where time dilates, length contracts, simultaneity breaks down, and velocity addition becomes nonlinear, and mass and energy becomes equivalent. Anyway, so Lorentz transformations. That means here you can see the mathematical equations on the screen. So to derive these equations, Lorentz did one thing: two coordinate systems were taken. Two coordinate systems were taken. X dash, y dash, dash dash. That is one coordinate system. Another one denoted by x, y, z. And they are moving. Say, for example, one is stationary and the another one is moving with a constant velocity with respect to the first one. And here you can see both the y-axis remain parallel to each other, and z-axis are parallel to each other, and x-axis are parallel to each other. And the direction of motion is the x. So that way, the formulae were derived by Lorentz, and consequences of these equations are what? There are actually 5 consequences. So first consequence is what? Time dilation. That means, for example, someone is moving inside a spaceship relative to you or relative to an observer on Earth. So in that case, what happens? Time dilates. That means clock, say there is a clock with the pilot of the spaceship, and you have one clock. You are sitting on Earth. Okay. So here the ticking of the clocks become different. Ticking of the clocks becomes different. The clock which is with the pilot in the spaceship ticks slowly. Okay, relative to you, relative to the observer on Earth. Means here time slows down. So this effect is called time dilation. The mathematical formula for time dilation you can see on the screen. Okay. So this is time dilation. Next is space compressions or length contracts. So here also you consider the motion. And here we are talking about speeds, high speed. I have already mentioned. That means all these speeds involved here are close to the speed of light. Though these are actually true for any speeds, but these effects become predominant in case of high speeds. Okay, all these equations, all these formulae are valid for all these speeds. It is not only for high speeds or speeds close to the speed of light, not that. Okay. Anyway, so next point is length contracts. Means contraction of length contraction. So say for example the same thing, space is again moving. Okay. And if you measure the nose to tail length, nose to tail of the spaceship, then in that case that length appears to be contracted, appears to become shorter with respect to the observer on Earth, because that spaceship is moving and you are standing on Earth or sitting on Earth. Okay, there is a relative velocity between the spaceship and you, and for the existence of this relative velocity, there is a contraction of length. Okay, the length actually contracts, means that appears to be shorter. In which direction? In the direction of the motion. That's why I mentioned nose to tail, that length. Okay, not other dimensions. Means you can consider also other directions of length, but not in those directions. In the direction of only motion. Okay, so that point was the second point, length contraction, and the formula you can see here on the screen. And the third point is relativity of simultaneity. Normally we know actually concept of now becomes invalid here. Okay. Say I am talking to a girl here on earth, but from a distant observer. Distant means, say for example, many light years away, few light years away, one observer is there, and say he is a man, he is observing us. I am talking to a girl. Say for my example, I am talking to my friend. Okay. So for us, we are talking to each other. That means this is now, means this is simultaneous since we are talking to each other. This is simultaneous. But for that distant observer, this event, we are talking to each other, so this is the event, that this event may not be simultaneous for the distant observer. This may happen. Say for example, a train is moving, okay, and you are standing on the platform. So if you notice that lightning strikes both ends of the train simultaneously, then in that case, the driver of the train may notice different times of striking. Different times of striking. For since it is appearing for to you to be simultaneous, so for the driver it will be different. It will be different means that that thing will not be simultaneous. And say for example, train is moving, you are standing on the platform and the train is moving. So if for the driver of the train, the event of striking appears simultaneous, then for the observer on the platform, that event won't be simultaneous. Because there is a relative velocity between the observer on the platform and the train. Since relative velocity is there, that's why the events won't appear to be simultaneous. So whether some event is simultaneous or not, that depends on the relative velocity between them. Okay. So that is called relativity of simultaneity. That means concept of now becomes actually invalid. Okay, concept of now. There is no now. Anyway, so this was the third point, relativity of simultaneity. Fourth point is also there, and fifth point is there. Fifth point is mass energy equivalence. Let's discuss the mass energy equivalence first. Mass energy equivalence, you know the formula, E is equal to mc square, and that is known as Einstein's famous formula. Here mass and energy both are equivalent, and the mathematical relation between them can be found out using this relation, where c is the velocity of light or speed of light, which is 3 into 10 to the power 8 meter per second in vacuum. That is known to you. And practical evidences are also there in case of particle accelerators. Means in the study of particle physics, scientists have found all these things to be true. Okay. And not only this one, time dilation, that is also true. Experimental verifications are there. In case of GPS satellites, experimentally this was verified. In case of particle accelerators, the same thing was verified. All these things we are discussing today here in this video are verified truth. Okay, these all are verified truth. These are not only in theoretical level, all are verified. Anyway, so mass energy equivalence, though this is known as the Einstein's famous formula, but origin of this formula means credit should go to Lorentz, Lorentz, because from his mathematical equations, Einstein derived this formula E is equal to mc square with the help of Lorentz transformations. So that means you can say that contribution to this formula goes to both Einstein and Lorentz. So here you can see mass and energy. In case of nuclear fission, same thing we can see. Mass is converted into energy. Okay. And so mass is energy. This way also you can say mass is energy because they are equivalent to each other. And there is one more consequence. What is that one? First one was time dilation. Second was what was that? Length contraction. third one's relativity of simultaneity. Okay. Fifth one, mass energy equivalence. One more thing is there, that is velocity addition. You know velocity addition in class 5, 6, 7, up to class 10 you have studied that, say two people are moving relative to each other, okay, and if they are moving in the same direction parallelly, okay, and in the same direction, then how you actually calculate the relative velocity between them? You just subtract one velocity from the other. Say one is moving with a velocity of 30 km per hour and another man is moving with a velocity of 20 km per hour. Then what is the relative velocity between them? 30 minus 20, that is 10 km per hour. This formula is known to you. Here the mathematical relationship is linear. And if they are moving opposite to each other, then in that case you just simply add up the velocities. 30 and 20. 30 plus 20 is equal to 50 km per hour. But if you think over this problem minutely, means if you take the help of Lorentz transformations, then you can see that the velocity additions are not linear. They are actually non-linear. And since non-linear, then you will get a drastic difference. You know that no way velocity can exceed the velocity of light. No way. Okay. But if you consider the laws of rules of classical physics, then and if you adapt that way, say one man is moving with a speed of 0.9 c, where c is the velocity of light or speed of light, and another man is moving with a speed of say, for example, 0.2 c. So if you add up those velocities, they are moving opposite to each other. Okay, so if you add all these two velocities, then what is the result? 0.9 c plus 0.2 c, that becomes 1.1 c, which exceeds c. 1.1 c, which is more than c. And this is not possible. This is not possible. So where is the discrepancy? Because you have linearly added the velocities. That is the problem. That is not actually correct. That is not actually correct. Okay. So for this one formula is there. You can see on the screen that formula. What is the actually relative velocity between them? And in all these cases, whether it is time dilation, whether it is length contraction, whether it is velocity addition, in all these things you can see there is one square root quantity, square root of 1 minus v square by c square, where v is the velocity of the object, c is the velocity of light or speed of light. Here this expression root over of 1 minus gamma square v square by c square, this is denoted by gamma, and this is called Lorentz factor. This is known as Lorentz factor. Okay, and you can see 1 minus v square by c square, v is always less than c. That means this under root quantity, square root quantity, is always less than 1. Anyway, so this was all about today's topic. Okay, Lorentz transformations, and means actually what was the topic of discussion? Consequences of Lorentz transformations. So 5 consequences are there. Okay, time dilation, time dilates, length contraction, length contracts. Okay, and all these things happen only in case of relative velocities. Here the frames, the two reference frames are here, they are not accelerating to each other. If they accelerate, then there will be a drastic change in the equations. Okay, if they accelerate, one frame is accelerating with respect to another one, in that case there will be a drastic change in the mathematical equations. Lorentz transformations cannot be applied in those cases. Only in cases where the one frame is moving at a constant velocity with respect to another one. In that case only Lorentz transformations can be applied. Anyway, so this was all about today's topic. If you found this video fascinating, please like, share and subscribe to our channel. And this is the end of this video. Thank you. Thank you for watching this video.